summarize what we've learned before moving on to something new. All right, question 18.2. This PV diagram shows 3 possible states of a certain amount of an ideal gas. Which state is at the highest temperature? And if it's hard to tell, 2 and 3 are vertically aligned. All right, anybody need more time? Nope. All right, who thinks state 1? 1 vote. Who thinks state 2? Who thinks state 3? 1, 2, 3, 4, 5, 6, 7. Who thinks 2 of these are tied for highest? Who thinks all 3 are at the same temperature? Okay, so most people voted for C, state 3, and you would be correct. If you can visualize the isotherms here, there'd be an isotherm here, and then another one that 2 runs along, and then another one that 3 runs along. And we said that the isotherms increase in temperature the higher you get. So state 3 would have the highest temperature. All right, question 19.4. In an isothermal expansion of an ideal gas, the amount of heat that flows into the gas is what? All right, anybody need more time? Okay, who thinks the answer is A? Who thinks the answer is B? 1, 2, 3, 4, 5, 6, 7, 8. Who thinks it's C? Who thinks it's D? Who thinks it's E? All right, everybody who voted got the correct answer. We just wrote it on the board. Q is equal to W. That's all you need to know. Okay, so any questions on that one? All right. Okay, question 19.9. An ideal gas begins in a thermodynamic state A. When the temperature of the gas is raised from T1 to a higher temperature T2 at constant volume, a positive amount of heat flows into the gas. If the same gas begins in state A and has its temperature raised from T1 to T2 at constant pressure, the amount of heat that flows into the gas is what compared to Q12? Who needs more time? Okay. We're good? All right, who thinks the answer is A? 1, 2 votes. Who thinks it's B? 1, 2 votes. Who thinks it's C? 1, 2, 3 votes. 4 votes. Who thinks it's D? Who thinks it's E? All right, so no consensus, no clear consensus one way or another. There's a whole lot of information packed into this problem. So the first thing it says, when the temperature of a gas is raised from T1 to T2 at a constant volume, what process is happening?
Isochoric.
Isochoric. Okay, so our picture is straight up and straight down. And it says that it's going from a lower temperature to a higher temperature, so we know that we're going up. Okay, and so there's an isotherm here, T1, and a higher temperature isotherm there called T2. Actually, I need to make that dip a little lower. Okay, and then it says that a positive amount of heat flows into the gas. So I could say, so we said that's isochoric. Has plus Q12. And the equation for isochoric for Q is NCV. Yeah.
CV in this case, it's like single gas or a single.
It doesn't tell us, so at this point we don't really know CV. So we'll just hold it there and move on to the second sentence. If the same gas begins in state A and has its temperature raised from 1 to 2 at constant pressure, so what kind of process is that? Isobaric. Okay, so that's a flat line. So we're going from the same initial state and we're going to the same final temperature, so we're going to hit T2 going this way. Okay, so isobaric, we've got a plus Q, I'll call it Q13 because we're going to this new dot 3 I labeled. And isobaric, the equation for Q is NCP delta T. Now it's the same gas, so we know that the N's are constant between these two cases, and the temperature change is the same, so this is the same for both processes. And so the only thing is the CV and the CP value, right? And so we look down here and we can calculate CP. CP is equal to CV plus R. And CV values, by the way, were all positive. And so what does that mean about the CP term related to the CV term? It's greater, yeah, CP is greater than CV. And so that's the only thing that we didn't really know, but all we do know is that this term is bigger than this term, therefore Q13 has to be bigger than Q12. Yeah. Any questions on this one? This one's hard. It's got a lot of stuff crammed in there. You guys feel comfortable with it now, kind of seeing it broken down? What if you saw this on the test?
Next week's test?
Next week's test. Could you handle it?
No. I don't know. Maybe I'll
Yeah, Leland?
Are we going to have to know each of these processes? Like, are we going to have to know that the isochoric is the, Q, N, CV?
Yes, indeed.
Okay.
Yeah. And this table is not on your cheat sheet.
That's what
So this table would be a really good thing to put on your, sorry, it's not on the equation sheet that comes with the test. This would be a good one to put on your cheat sheet, most definitely. So you'll just get, like, in general, like delta U is Q minus W, and delta U is NCV delta T, because that's true for every case. But as far as the individual things we calculated, that's up to you to remember or write down. All right. next one, we're going to use this picture for a few questions. An ideal gas is taken around the cycle shown in this PV diagram from A to B to C back to A. Process B to C is isothermal. For process A to B, what do we know about Q and delta U? Does anybody need more time? No? Okay. Who thinks the answer is A? Most people. Who thinks it's B? One vote. Who thinks it's C? Who thinks it's D? Who thinks it's E? All right, so majority said A. Can someone who said A tell me why you said A?
Because W is 0.
W is 0, but what do we know about Q and delta U?
They have to be, because it's W is 0, so they have to be same.
They're equal, but this question isn't asking whether they're equal or not. It's asking whether they're positive or negative.
It goes up, it's positive. Arrow goes up.
So the arrow goes up. We've only really talked about the arrow direction telling us something about work, but what does the arrow going up tell us about heat?
The higher it up, the more heat there is.
Yeah, so we're going to a higher temperature, therefore we had to add heat to the system. Yeah, okay. Good. Yeah, so this stuff tells us that they're equal. And then looking at the picture, we know that heat has to be positive, therefore both delta U and Q have positive heat, or positive values. Okay, so the answer is A. Same graph. Now we're asked about the process from B to C, and that they're reminding us is an isothermal. All right, hopefully this one went fast, right? Okay, so who thinks the answer is A? Who thinks the answer is B? 1, 2, 3, 4. Maybe I didn't give you guys enough time to think about it. Anybody need more time on this? Okay, I'll wait. Okay, all right, so the reason I stopped at B is because I'm hoping that this was one that you could all kind of get that was B. And so I only got 4 people that voted for B. So how many people are voting for B now? Everybody, all right, very good. So we don't need to go on because B was the only option where delta U was 0. And so we can quickly scan and see that the other options are not going to work for us, so must be B. Any questions on that one? All right, the last pathway we're going to look at with this picture is from C to A. All right, does anyone need more time? Okay. Okay, I'm going to call it. So who thinks the answer is A? 1, 2. Who thinks the answer is B? Who thinks the answer is C? Who thinks the answer is D? 1. Who thinks the answer is E? 8 or 9. All right. So somebody who chose E, tell me why you chose E.
The change of temperature goes down.
The temperature goes down.
Because if you pretend to look at it like an isotherm for when it goes from C to A, that would be a lower temperature.
Yeah, so if this is on this isotherm, A is on another isotherm that would be a lower temperature. So it's a negative temperature. Remind me, Grant, what process is this called?
Isobaric, I believe.
Isobaric, yeah. Okay, so we look at our equations for Q and delta U. For isobaric, they both have that delta T term. So if that's negative, then Q and delta U are both negative. Okay. One more question using this picture. So the correct answer for this one was E. All right, so we've got the same picture, and we want to know for this complete cycle, so from A to B to C back to A again, how do Q, W, and delta U look?
Is this like physics where you walk around and if you end up at the same place where you have been, you didn't do your work?
This is not, because these processes are path dependent. So if it was path independent, then there would be no work done. Good question. All right, does anyone need more time? Okay, who votes for A? 1, 2, 3, 4, 5. Who votes for B? Who votes for C? 1. Who votes for D? Who votes for E? So for those of you who voted, most people voted for A. So somebody who voted for A, tell me why.
I sort of guessed. I thought because when the integral going to the right, so work would be greater going from B to C than it would be subtracted going from C to A.
Okay, so work is positive for the cycle.
So that ruled out U and E, and then I thought that delta U would be 0 because you just ended up in the same place where you started.
Uh-huh.
Being an isotherm.
Okay, so that is true. You are correct, and this is something I didn't write on the board, but this was on the last slide we had in the presentation, summarizing for a cycle. Delta U is 0 for what same reason John said, because you end up back where you started. So the change in internal energy is 0. And then Q cycle equals work cycle. So using John's logic about how we figured out work is positive, then we know that Q must be positive And so that makes answer A the correct answer. So the only thing that's not on the board that would have been necessary to help answer this question is Q cycle equals work cycle, and delta U for the cycle equals 0.
Why do you say the work is positive?
Because if you thought about the area under the curve between B and C, it would be greater than the area under that flat line between C and A. So you can subtract that small rectangle from that curve.
Yeah, so that's a good point. So work for the cycle is calculated by taking the sum of all the works for each step. So you'd have the work from A to B, the work B to C, and then the work from C to A. And the only one that's 0 is going from A to B. So B to C, the area under that curve, is a big positive. And then work from C to A is a little negative. And so the net result is something positive.
So when we go from C to A, the area underneath the C and A line is the work done?
It's, yeah,
Okay.
yeah,
It's negative because
Because it's moving to the left.
yeah. All right, so this has kind of forced us to use everything we've learned so far, so you can kind of get a sense for how important having all this information in your notes is. Yeah, Leland?
I'm kind of confused why the total internal energy, like in the full cycle, is 0. Is it that it doesn't change, or is it that it changes but then it all adds up to equal 0?
That's correct.
Okay.
Yeah, so we said from here to here, then what would your internal energy would be positive. From here to here, your internal energy is 0. And then from here to here, your internal energy is negative. And so it just so happens that whatever you gained here, you lost there.
The equation was like the same as you would S of S of
Oh yeah, there you go. So delta U was NCV delta T and NCV delta T. Yeah, so this is, this can be a workout problem too, where this is your worst nightmare, where for every single step you have to actually calculate a value for Q, W, and delta U, and then your very last step is to sum them up and make sure that you get this. I think you have a homework problem like that. So, yay! All right. Okay, so there's a few more of these questions we'll go through. An ideal gas is taken around the cycle from A to C to B, let's see, A to C to B, and back to A. Okay, that's a little confusing. So it's going A to C to B, back to A. And then this pathway is now adiabatic. Okay, so now we're answering questions for the adiabatic pathway.
So how would I know by looking at the pictures of the baby?
You wouldn't know from looking at the picture. You only know because they tell you. I think I made a mistake on my drawing here. My drawing would lead there to be 2 possible correct answers. But I think that I made a mistake. So before we answer this, let's go back to the adiabatic slide, because I took liberties with what we were shown. All right, so the adiabatic slide shows that the adiabatic pathway goes, it's climbing from a low temperature to a higher temperature, or from a higher temperature to a low temperature, depending on which way you go. And I took liberties with that and said it could go like this instead. And I think that I was wrong, because if that was correct, then we wouldn't be able to answer that last question we had. So, all right, so let's fix that. Okay, so we can only follow this pathway. We can go up or down that pathway, but that'll make a difference. So let's go back to this question. All right. All right, anybody need more time? Nope, okay, who thinks the answer is A? Who thinks the answer is B? Who thinks the answer is C? 2 votes. Who thinks the answer is D? 1, 2, 3, 4 votes. Who thinks the answer is E? Nobody, all right. So no clear consensus. So adiabatic case here, looking at our equations, Q is 0, so our answer has to be either C or D, which is what you guys voted, either C or D. Using just our knowledge about the work under the curve and the direction of the arrow, we know that the arrow is going to the left, so the work under the curve has to be negative. And so that information tells us that the answer would have to be D, because C work is positive. And then just verifying, we can see that whatever work is, delta U is the opposite of it. And so if work is negative, delta U is positive. Yes, that's what's in question, or answer D. So that's the correct answer. All right, so any questions on this last clicker question?
So did you say that the volume, as the volume increases, work will increase? Is that always the case?
As the volume increases, work increases.
Or rather, they're proportional?
Yes. Yeah. Yeah, Leland?
So is that equation for work already take into account then that you're moving, that it's going to the left, that you're doing negative work? Or
It does, because our delta T here, you're going from a low temperature to a high temperature. So your delta T going this way would be positive. So this is a positive term. The only way that work is negative is the negative out front. Yeah. That's a good question. Okay.